Hello. In this video, we're going to give a quick overview of our composition of transformations. So the last few days, we had been talking about reflections, translations, and rotations independently, and now we're going to put them together. So here, for this example, okay, consider point A at -2, 5. The first thing we want to do is we want to translate this point 3 units down and 4 units right. Then we want to turn around and rotate this 90 degrees counterclockwise. Okay. We want to end up at the new image A prime prime. When it comes to a composition of transformations, take it one step at a time. Let's start with the translation. If we look at the rule is going to say x, y for our translation should be x plus 4 because we're going right 4, but then y minus 3 because we're going down 3. So instead of doing all the transformations all at once, let's go ahead and move A. Let's go ahead and move A. A was at -2, 5, but after this transformation, -2 plus 4 is a +2, and then 5 minus 3 is also a +2. So the next thing that we have happen is we have the rotation 90 degrees counterclockwise. So let's again look at the rule. If we just started at x, y, and we wanted to rotate 90 degrees counterclockwise, our rule would say y comes in, but it has the opposite sign now. And then we have x. But we're picking up at the 2, 2. So I didn't write it, let me write it now. Okay. This 2, 2 is A prime. So now we're going to do the rotation to this 2, 2 and say A prime is at 2, 2, but our 90 degree counterclockwise rotation switches x and y, but makes that first one have the opposite sign. So now we're at -2, +2. So when it comes to the composition of transformations, we want to go just one step at a time. Now, the extra piece to this that you may see pop up would be, what's the coordinate notation? What's the coordinate notation? Okay. Let's piece this together real quick. We started off with x, y, but then we had our translation. Our translation said we're going to have x plus 4, y minus 3. The next thing that happened in our progression was the rotation 90 degrees counterclockwise. This is just where we have to really be careful. We saw above that the rotation counterclockwise 90 degrees made x and y change spots. It still happens here. You're going to have your y minus 3 come inside, and now your x plus 4 goes to the outside, because these things flip spots. But the other thing that happens with the y coming inside is now we need to change that sign as well. So if we're looking at going from the beginning, A, to the end, A prime prime, our rule is going to be xy goes to -y plus 3. We're distributing that negative, and then x plus 4. So this is the rule that we have. Let's see another example. We want to reflect the 0.14 across the y-axis and then just translate this 3 units down. Again, our question says, what are the coordinates of the image B prime prime? So let's take this one step at a time. Okay. With our reflection across the y-axis, we're going to start off at xy. We're going to reflect across the y-axis. Remember, when you reflect across the y-axis, the x has the opposite sign, but y stays the same. So as you're looking at this, as you're going from one point to the next, just do this one step at a time. B is going to be at 1,4, but after this reflection, now it's going to be at negative 1,4. That's the reflection. The next thing that happens, looking again at this independently, is if we just had x, y, and we wanted that translation now. This is 3 units down, so this would just take x and leave it the same, and then take 3 away from the y, y minus 3. Let's pick up where we left off. B prime is at negative 1,4. But if we're just translating this down 3 units, we're going to be at negative 1, now positive 1 with B prime prime. I don't want you to overthink the compositions, especially if we're just asking you to go from one point to the next. Just do that first transformation, get that set up, and then from there do the second transformation. Let's see what happens if we want the coordinate notation for this one as well. The coordinate notation. This is where we had to make sure we follow the rules. With the coordinate notation, we are always starting with x, y. Our first task was the reflection across the y-axis. So as we saw above, x has the opposite sign, y stays the same. But from here, now we want to translate that. And we just wanted to translate this 3 units down. So this becomes negative x and then a y minus 3. So the coordinate notation going from the very beginning to the very end would be xy goes to negative x and then a y minus 3. This is the rule that takes you from the beginning to the very end. We have one last example to look at. Consider the point C at negative 3, negative 4. We want to rotate this 180 degrees counterclockwise and then reflect this across the x-axis. I'm going to change it up because I'm going to go ahead and get us the rule in place first. And then once we have that rule, we can just follow it across. So for instance, we're going to start off at xy, we always do. We want to rotate this 180 degrees counterclockwise. Remember, when we rotate 180 degrees counterclockwise, x and y stay in the same positions, they just have opposite signs now. From here, we did the rotation. Now we just want to reflect this across the x-axis. So as we reflect across the x-axis, remember that x stays the same. So we had negative x at this spot. It's going to stay negative x here, but then y has the opposite sign. Okay, so here we had negative x, negative y, and we're reflecting this, so x stays the same. In fact, let me kind of highlight it this way. Our x stays the same. Our y is what changes signs. So our rule here is going to say x, y goes to negative x, positive y. The benefit of setting it up this way is now I can ask you any question. If you want to take c at -3, -4 and figure out where it goes, you have the rule in place. So c at -3, -4 to c prime prime, we know that x will change its sign, but y will stay the same. So this would still be 3, -4. Finally, as an extension, can we go backwards? I want us to keep the same transformations, the same series of transformations, but now suppose we ended up at the point 1, 3. My advice when we're working with the pre-image is to go ahead and still have the rules in front of us. We start off at x, y. We had a rotation of 180 degrees counterclockwise, and that put us at -x, -y. And then we had a reflection across the x-axis, which says that, hey, x stays the same, and then y changes. So here, we're starting off with the a prime prime, and we know this is at 1, 3. We want to know, what did we do to go from a prime to a prime prime? And then what did we do to go from a to a prime? We have to work backwards here. So think about your reflection. With your reflection, your x stayed the same, your reflection across your x-axis, your x stayed the same, but your y changed signs. So if we ended up at 1, 3, but the x stayed the same, then a prime is still at 1, but the x coordinate would have to have been -3. Okay? We have to work backwards. Here, going from the original to the a prime, we know that x and y both flip signs. So if we ended up with 1 on a prime for the x coordinate, we had to have started with -1. And then if we ended up with -3 on the y coordinate, we had to have started with +3. So this is where we started. My biggest piece of advice when you're trying to work backwards and find the pre-image is, once you have that pre-image, run it back through and make sure you end up back where you should have started with. Okay? So if we have -1, 3, and we do a rotation of 180 degrees counterclockwise, remember, x and y both change signs, so this would be +1, -3. And then we're reflecting across the x-axis. Well, reflecting across the x-axis means that the x stays the same, but now we have the opposite sign. So if we started at -1, 3, which we claim to, we should have ended at 1, 3. In accordance to the problem, that's exactly where we were. I hope this video clears up any misconceptions. If you have any questions, please reach out to us.